So let us once again have a revision. Let us once again have a revision on absolute convergence. So suppose that you have a series summation un which has both positive and negative terms. So it may not be necessarily a alternating series. I am not talking about only alternating series. It may be alternating series or it may be a series with a few terms positive, few terms negative. Necessarily it may not be a series with alternate positive negative. Okay. So if it is alternate, that is okay. This definition is also for alternate, and it is also for the series which has a few terms positive, few terms negative with undefinite pattern. Okay. So summation un with both positive and negative term is said to be absolutely convergent. So that series is said to be absolutely convergent if summation mod un, which is now have become what the series with all positive term is convergent. So this is said to be absolute convergent. This series summation un is said to be absolute convergent. Note that n is from 1 to infinity. So this series with both positive negative term is said to be absolute convergent if what summation mod un is convergent. Summation mod un is convergent. So for showing what that certain series is absolute convergent, you are supposed to show that summation mod un is simply convergent. And see, you can show that summation mod un is convergent by your previous test. That is, you can use p series, you can use your geometric series condition, you can use the comparison test, you can use your D'Alembert's ratio test, you can use your Cauchys root test. Okay, so all the tests you can use, and if it is convergent, then in that case summation un is said to be absolute convergent. If summation mod un is convergent, then summation un is said to be absolute convergent. Okay. Now what is the conditional convergence? If summation un with both positive negative terms is convergent, and if the corresponding mod summation un with all is divergent, then summation un is said to be conditional convergent. So summation un should be convergent, okay, and what summation mod un should be divergent. So summation mod un, if it is divergent, okay, then you have to check that summation un should be convergent. If it is happening, then summation un is called a conditional convergent series. Okay, now every absolutely convergent series is convergent. Okay, converse is not true. So if you have absolute convergence series, we can simply say that it is also convergent. Okay, any convergence series of all positive terms is absolutely convergent. Obviously, if you have what summation un, which is a series of positive terms, then definitely if it is convergent, then summation mod un also will be convergent, and therefore it is a absolute convergent. That's why these two notes are very important. They may be part of your MCQs. Okay, test the series for absolute or conditional convergence. Okay, so what I'm going to do now is I'm going to write un. What is un? You can observe that first term is 1 upon 3 raised to 0, second term is 2 upon 3 raised to 1, okay, third term is 3 upon 3 raised to 2 with alternatively plus minus sign, okay, and plus and so on. There are infinite many terms. So I can guess that. Okay, now I'm not going to discuss how we got this un. So definitely what this sign is minus 1 raised to n minus 1. So 1 2 3 4, therefore first term is 1, second term is 2, third term is 3, therefore nth term is n, and 3 raised to 0 is first term, 3 raised to 2 is second term, 3 raised to 3 is 3 raised to 2 is third term, 3 raised to 3 is fourth term. Therefore we have what 3 raised to n minus 1 as nth term. So this is your un. So summation mod un. What is summation mod un? This just remove this minus 1 raised to n minus 1. We get summation mod un, which is equal to n divided by 3 raised to n minus 1. Okay, and now let us have that some mod un, and let us what use your D'Alembert's ratio test. Okay, limit n tends to infinity un plus 1 divided by un. Here I have taken mod because it is terms with both positive negative terms. We have to make it positive, then only this condition can be checked. So if you simplify this limit, you will be getting answer equal to 1 by 3, 1 by 3 is less than 1. By D'Alembert's ratio test, summation mod un is convergent, therefore summation un is absolutely convergent. Okay, second example is 2 by 3 minus 31, 3 by 4, 1 by 2, 4 by 5, 1 by 3, minus 5 by 6, 1 by 4, and so on. So this can be what written like this. Further we can have, again we can use your D'Alembert's ratio test, and you will find that that series is what value having what we have we are using here comparison test. Okay, sorry, I am not using here DLMS ratio test, I am using here comparison test. So you will observe that summation u and summation vn, what will converge diverge together, because L is here 1, which is finite not equal to 0, and here you will find that summation vn is 1 upon n power is 1, which is p series with p equal to 1, therefore it is divergent. So summation un divergent. Now in order to show that it is conditional convergent, you are supposed to show that summation un converges, and what we can show that it is convergent with the help of the Leibnitz theorem that we have applied. So these two conditions are obviously satisfying, therefore what it is convergent, summation un convergent and summation mod un is divergent, therefore this series is not absolutely convergent, it is conditional convergent. Okay, so I hope that I have given you justice with this unit with this exercise. Now I am going to finish out. Thank you.